Wildfires are spreading fast in Canada. Strengthen forests for the future. Published in Nature, Volume 633, published September 12, 2024, by Christopher Mulverhill, Nicholas C. Coops, Jan Boulanger, Kira M. Hoffman, Amy Cardinal Christianson, Lori D. Daniels, Maude Flamand-Hubert, Amy R. Wotherspoon, and Alexis Achim. As wildfires become more frequent and severe, efforts to improve the resilience of forests must be grounded in data and led by Indigenous peoples. At the end of July, a wildfire driven by extreme winds blazed through Jasper National Park in Canada, forcing the evacuation of 25,000 citizens and visitors. For a month, more than 350 firefighters worked to control the fire, which grew to cover 33,000 hectares, making it the largest wildfire in the park in at least 100 years. Last year's fire season was also catastrophic. About 4% of the nation's forest area burnt, 15 million hectares, more than twice the previous record, set in 1989. Wildfires are not always bad. They have been fundamental to forest ecosystems for hundreds of millions of years, affecting the composition, structure, and biodiversity of landscapes. Some plant species, such as jack pine and lodgepole pine, require the heat and smoke generated by fires to release their seeds from a resin-coated cone and to germinate. But wildfires in Canada have been increasing in number, size, and intensity since the mid-20th century. This is mainly the result of anthropogenic climate change and the accumulation of undergrowth and other fuel after decades of fire suppression as a way to manage forests. The situation is dire, but not hopeless. In many parts of the nation, efforts are shifting from suppressing fires to a variety of responses, including lighting-controlled fires to manage vegetation, often referred to as prescribed burning. Indeed, 2 decades of such proactive fuel mitigation in the forests surrounding Jasper has meant that firefighters were able to save around 70% of the town's infrastructure after the July wildfire. As forest scientists and fire practitioners, we urge the public and those involved at all levels of forest management to think about fire more holistically. As humanity prepares for a future in which fires become more common, we need all the tools at our disposal. 2 sources of knowledge that are often overlooked are crucial: Indigenous-led fire stewardship and technological advancements in data acquisition. Indigenous-led stewardship. Humans have used fire to influence landscapes for millennia. Indigenous peoples around the world continue to recognize the importance of fire stewardship to maintain desirable, diversified, and resilient ecosystems and to achieve cultural objectives that have ecological benefits. Many Indigenous communities use fires for a variety of purposes, from protecting nearby infrastructure and settlements to managing territories for crops, food, and medicinal plants. For example, First Nations communities across Canada use fires to boost the abundance, productivity, and nutritional value of huckleberries. Wildfire agencies in Canada are beginning to show an interest in incorporating Indigenous fire practices, known as cultural burning, into forest landscape planning processes. For example, the We Are Fire project involves Indigenous knowledge holders using cultural fire practices to improve biodiversity in the Saskatchewan River Delta. Crucially, cultural burning is not something that can simply be captured and appropriated into plans by agencies to inform wildfire management. Indigenous communities, which hold the cultural, technical, and place-based expertise to engage in both proactive fire stewardship and wildfire response, must lead these processes and make decisions according to their cultural and ecological values. This is all the more important because Indigenous peoples disproportionately bear the burden of wildfire impacts through evacuations, alteration of their territories, and other adverse effects on their ways of life. Not everyone is convinced by the usefulness of prescribed and cultural burning, however. Some doubt the ability of public authorities to control the fires and worry that, in a rapidly warming and drying climate, the risk of a fire escaping beyond its intended area is too high. Such accidents can erode public trust. Research is needed to better understand and address this resistance. Practical restrictions also exist regarding who is allowed to ignite fires, who is responsible for each event, and who can approve and oversee the processes. Forest and landscape management planning processes must be revisited. The first steps must be to accelerate capacity in indigenous communities to participate in and lead wildland fire management. There should be more communication, joint training, and, importantly, overlap between Indigenous fire practitioners and wildfire agencies to share knowledge of fire behavior and its effects in a respectful way. This will help communities to devise practices that are grounded in cooperative and considerate fire management. Although the Canadian government has piloted programs and grants that focus on training and collaboration, more permanent funding sources are needed to ensure continuity of these successes. Measure, monitor, model. Advanced technologies should also be used more widely. Remote sensing data from satellites, aircraft, handheld devices, and drones can be used at all stages of fire, before, during, and after the event. Satellite data have long been used to track land cover and changes brought on by fire. They can also help to determine pre-fire fuel loads, monitor recovery, and identify areas that are less prone to burning. Known as refugia, such areas are valuable for regeneration after a fire and for conserving biodiversity. State-of-the-art technologies can map in exquisite detail the state of forest fuels, including species composition, soil moisture, vertical structure and connectivity, hotspots, and vegetation health. Future satellites will do even more. For example, Wildfire Sat, a joint program involving 3 Canadian federal agencies that is expected to launch in 2029, will be the first public satellite mission to be purpose-built to monitor wildland fire. It is designed to observe fires at their peak, typically during the afternoons when temperature, humidity, and wind are most conducive to fire activity, to track their boundaries and spread. It will also be able to measure radiative heat power so that resources can be prioritized to the most intense fires, particularly in remote northern communities in Canada, where early and safe evacuations are crucial. Researchers can improve models that measure emitted carbon and track fire spread to help reduce economic losses and improve public safety. In the past decade, drones have helped to characterize the structure of forests in great detail, including fuel loads and proximity to or connectivity between trees. They do this by, for example, measuring sunlight reflected from Earth's surface and gathering topographic data by emitting laser pulses and timing their return to a sensor. Such light detection and ranging LiDAR instruments can draw a 3D picture of fire fuel distribution by mapping forest height, cover, species, and crown attributes. Photographs from drones can assist firefighters and be used to help regenerate disturbed ecosystems after fires. Linking such drone-based data with fuel metrics, the amount of understory material such as shrubs and grasses that is present, is currently underway. Drones with onboard sensors are becoming cheaper, from hundreds of thousands of dollars a decade ago to a few thousand today. Their controls, mission planning software, and safety features have improved, and processing techniques are advancing, for example through machine learning and other types of artificial intelligence. These technological advances are beneficial only if they reach all relevant users, however, and they require users to be trained. Come together. Conversations led by Indigenous peoples and involving researchers and other knowledge holders must happen urgently so that local management strategies can be devised, and international collaborations between scientists and policymakers as well as between disciplines are a top priority that would help to mitigate the rise in the number and intensity of Northern American wildfires. This will require a huge effort, but there are precedents. In the 1980s, after the discovery of a hole in Earth's ozone layer over the South Pole that posed a major threat to human and environmental health, leaders worldwide agreed on the Montreal Protocol. Its aim was to phase out the use of ozone-depleting substances, such as the chlorofluorocarbons commonly used in spray cans and refrigerants. In doing so, they averted the collapse of a global Earth system. Now, there is evidence that the southern ozone hole has recovered and that ozone levels are on track to return to pre-1980 levels by the middle of this century. Cross-border arrangements such as the U.S.-Canada Air Quality Agreement also showcase success and opportunities for collaboration. The same level of international urgency is needed for wildfires. Environmental assessments must be done, both domestically and across borders, to explore how to mitigate fires and coordinate efforts. At local or regional levels, conservation economies should be put in place, in which members of a community are employed to protect carbon and biodiversity. Existing Indigenous guardian programs should be supported, including financially, and expanded. Wildfire is a crucial ecosystem process. Proactive management led by Indigenous peoples and supported by advanced technologies is key to decreasing fire risks and increasing resilience in forests. Only with such a change in perspective can forests be protected in Canada and beyond. The authors. Christopher Mulverhill is a forest monitoring researcher at the University of British Columbia, Vancouver, Canada. Nicholas C. Coops is a professor of forest science at the University of British Columbia, Vancouver, Canada, and holds a Canada Research Chair in Remote Sensing. Jan Boulanger is a forest ecologist for the Canadian Forest Service in Quebec City, Canada. Kira M. Hoffman is a fire ecologist at the University of British Columbia, Vancouver, Canada, and a fire practitioner in British Columbia. Amy Cardinal Christianson is Métis and works on Indigenous fire stewardship with the Indigenous Leadership Initiative team in Rocky Mountain House, Treaty 6 territory. Lori D. Daniels is a professor of forest dynamics and head of the Centre for Wildfire Coexistence at the University of British Columbia, Vancouver, Canada. Maude Flamand-Hubert is a historian at Laval University in Quebec City, Canada. Amy R. Wotherspoon is a climate and forest management researcher at the University of British Columbia, Vancouver, Canada. Alexis Achim is a professor of forestry and wood science and vice dean of research at Laval University, Quebec City, Canada.